This is Kokilavani from the Department of IT. I am going to teach an Foundation of Data Science concept. First lesson, what is an data science? Data science is known as an data-driven science, that is an science to extract the knowledge from the data. It is an interdisciplinary field about the scientific methods, process and systems to extract the knowledge or insights from the data in that various forms, either the structured or unstructured. Data science is a new field of study which is a combination of statistics, machine learning, data analysis and programming. So in data science is extracting the knowledge from the data. The components of data science: statistics. Statistics is analyzing and interpreting the data. It's identifying the patterns and relationship by using the statistics. Mathematics. Mathematics provides algorithms and models, and it supports the optimization and predictions. And then programming. In programming, we used data processing and analysis. The common languages used in the data science is in Python and R language. Domain knowledge, understanding the specific industry or the problems by using the domain knowledge. And then machine learning builds the models that learn from the data. It creates the models that are developed by using these data. And data visualizations, that is presenting the information through the chart and graphs. It delivers the content in the visualizing manners. Then importance of data science: it enables better business decisions through the data analysis, and it also helps to identify trends and the customer behaviors. It improves the operational efficiency, and it supports predictive analytics for future planning, and it also creates some competitive advantages for organizations. It's essential for innovation in modern industries. So basically, the data science is used in many fields, like in business and any other fields. And next one is a data scientist. Data scientist is someone who use their skills to mine the data, understand it, and extract insights from it. They usually works with a team of engineers and analysts to create models that can be used for various purposes. So data scientist is an persons who use their skills to mine the data as a data scientist. In data analyst is work on getting the information from the various sources, such as offline or online databases, spreadsheet and surveys and so on. And this they can use the analytical tools like in PowerPoint, Excel and Tableau, like that. But mostly rely on the statistical techniques to present their findings in a readable formats. And data engineer who then build the applications that collect and process the data using the technologies like an Hadoop and Sparks, while ensuring its quality so it can be used by other teams such as an analyst or scientist without any issues. That is a data engineer. Then data architect. Then architects roles include the designing databases according to specific requirements, so they function efficiently without an organization infrastructures. Next one is in benefits of data science. It improves business predictions, helps in the sales and marketing, and increases the information security and complex data interpretations, and highly paid jobs and career opportunities. Automating the requirement process, these are in these areas we can use the data science concepts. And the applications of airline route planning, finance, that is in stock market, image recognition, fraud and risk detections, healthcare sectors in mainly for the decision predictions, and transports using the driverless cars, and e-commerce, Flipkart like Amazon's, like that. Then online gaming and delivery logistics. So in these areas we can use our data science concepts. Then facets of data, that is in form of the data. The data can be present in these forms that are structured, unstructured, natural language, machine generated, graph based, audio, video and images, streamings. So then we see one by one. Structured is an data that depends on the data models and it fixed within an record. So it easily to store the structured data in a table with the database or the Excel files. So SQL is a structured query language is preferred way to manage and query data that resides in the databases. So structured data is having the some fixed field within this records. Then unstructured data, so that is unstructured data, it's like our content that is in context specific, that all comes under the unstructured data. For example, our regular email, so that is in a there is a content in our email that also like in a paragraph, that also comes under the unstructured data. Then next one is a natural language. Then natural language is like an unstructured data. It's challenging to process because it's require knowledge of specific data science techniques and linguists. And a human written emails also a perfect example for the natural language. And the machine generated, so that machine generated data is generated by the machines, and that like computers. While processing the data, the machine can create and data that all comes under the machine generated data. For example, machine data are the web server logs, call details records and network event logs. These are the examples of the machine generated data. Then graph based, so the graph is like an vertices. So some vertices is connected by using the edges, right? So here we can easily connect the persons by using the edges, and we can easily accessing the data by using the edges. So the data is called as a graph based data. Then audio, image and videos, so in the data are in the audio format, in image and videos, these are comes under the audio, image and video data. And streaming data, so streaming data, it's like an we can for example the live sports and music events, that data are comes under the streaming data. Then data science life cycles, so first phase in data science life cycles, the first is data collection. In data collection we can get the data from the various sources, that is in an online or offline or other third party vendors. In data, next one is in data cleaning. After getting the data from the various sources, we have to removing the errors and inconsistencies from the data. After cleaning up the data, we have to explorating the data. That means we have to understanding the data characteristics, that is done in that phase. After that, we have to analyze the data. That means we have to identify the patterns and insights which are present in the data. After analyzing the data, we have to build the models. That model is created by using some machine learning techniques. After that, we have to evaluate the model. We have to measure the performance of that models. After the performance measurement, we have to deploy that. With deployment means we have to implement the models in our real world systems. So this is an data science life cycle diagrams. So first is define business problems. After that, the data collection, then goes to the data preparation, then data exploratory analysis, that is in data explorations. After that, we have to build in models. After building up the model, we have to evaluate that model, that is in performance metrics that are checked in that phase. After that, we have to deploy, that is in implementing our model in the real world systems. So here defining the business problems. So here we have to define the defining our problem first. First of all, we have to take in one real world problems, uh, and we have to consider the practical thing to do is to know what exactly the problem is. After finding the problem, we can do our data lifecycle process one by one. In that data science life cycle, we using the univariate analysis and bivariate analysis. In univariate analysis, we analyzing the data only that variables. The main purpose of univariate analysis is to describe the data and find the patterns that exist within it. For examples, central tendency, that means we have to find the mean and median and mode. Then variability, the ranging, interparatal range, and standard deviation variations. Then box plot, histograms, pie charts. These are used in the data visualization techniques. Next one is in bivariance. In bivariant, we can analyzing the two variables. In bivariant analysis, we understanding the relations. We have to understand the relationship between that two variables. In that, we using the scatter plus correlation coefficient and simple linear regressions. These are the concepts used in the data science life cycle. Thank you.